The most powerful army of World War II was not stopped by enemy fire. It was stopped by weather, distance, and broken machines. That is the paradox history rarely talks about. In 1944, armies did not grind to a halt because they ran out of courage. They stalled because engines froze solid, roads disappeared overnight, and vehicles designed for war failed against forces no one could shoot back at. Blizzards, mud, distance. Every doctrine assumed machines would keep working. Every plan assumed repairs would happen somewhere safe, somewhere behind the lines. But when the environment itself became the enemy, those assumptions collapsed. And that is where this story begins. Not with generals issuing orders, not with weapons changing the battlefield, but with ordinary people facing a simple choice: follow the rules or keep others alive. Across the war, solutions emerged that were never approved and never meant to exist. Machines were modified in the field. Systems were rebuilt on the fly. Vehicles were turned into tools they were never designed to be. These were not innovations born from factories or command rooms. They were improvised answers forged under pressure when manuals stopped offering solutions and time ran out. History celebrates the machines that destroy. It rarely remembers the machines that kept men moving, evacuating, surviving. There are no medals for modification, no honors for logistics, no monuments for the people who quietly beat impossible conditions with altered steel and stubborn resolve. Yet without them, entire campaigns would have failed long before any decisive battle was fought. This is not a story about brilliance or heroics in the traditional sense. It is a story about belief. Belief that broken machines could be reshaped, that ordinary hands could outthink impossible conditions, and that sometimes winning a war has nothing to do with firepower at all. Sometimes victory comes from modifying what you have, breaking what you're told not to touch, and pushing forward when the environment itself says stop. And when that happens, history changes without ever writing their names down. If you're interested in the hidden side of World War II, the machines, decisions, and people history rarely talks about, make sure you're subscribed. This story only gets more intense from here. By late 1944, the Allied war machine looked unstoppable on paper. Factories were producing weapons at a scale the world had never seen. Convoys stretched across continents. Air power dominated the skies. Yet beneath that image of overwhelming strength was a fragile assumption that machines would always work. Modern warfare depends on movement. Supplies must arrive on time. Vehicles must start in the morning. Aircraft must return, be repaired, and fly again. The entire system assumes continuity. But the war was not fought on paper. In places like the Ardennes, Italy, and the Pacific Islands, the environment began to dismantle that assumption piece by piece. Winter did not simply slow operations. It attacked them. Engines thickened as oil turned to sludge. Batteries died overnight. Metal contracted and cracked. Roads vanished beneath snow or dissolved into mud. For the first time, logistics units were not fighting enemy sabotage. They were fighting physics. Doctrines written in peacetime offered no answers. Maintenance manuals assumed controlled conditions, spare parts, and stable supply chains. Repair schedules assumed damaged equipment could be withdrawn to depots far from danger. None of that existed anymore. When the weather closed in, there was no rear area. There was only the line where things still moved, and the line where everything stopped. And when things stopped, men began to die without a single shot being fired. Ambulances could not reach the wounded. Fuel trucks froze in place. Aircraft limped back from missions only to sit idle, damaged beyond what standard field repairs allowed. Commanders could issue orders, but orders could not thaw engines or clear roads. This was not a tactical failure. It was a systemic one. The war had outgrown its own rules. Military organizations are built on procedure for a reason. Standardization saves time. Regulations prevent chaos. In theory, every problem already has a solution written down. But war has a habit of creating problems faster than doctrine can adapt. By 1944, the Allied machine faced situations no manual had prepared for. Vehicles designed for European roads were pushed into frozen forests. Aircraft built to operate from established airfields were forced to fight across oceans with nowhere safe to land. Repair chains assumed parts would arrive. But parts could not arrive if the machines meant to carry them were immobilized. In this environment, the enemy was no longer just human. It was distance. It was temperature. It was the simple fact that steel does not care about strategy. Every breakdown created a ripple effect. One truck failed, and a supply column stalled. One aircraft could not be repaired, and an entire mission timetable collapsed. Every delay multiplied the pressure on the system. The official response was predictable. Wait for better conditions. Follow procedure. Do not improvise. But waiting cost lives. Men trapped in freezing conditions did not have the luxury of doctrinal patience. Wounded soldiers did not survive long enough for regulations to catch up, and frontline units could not fight if the machines behind them failed silently. This was the moment when a quiet divide emerged inside the war effort. On one side were the rules. On the other was reality. Some officers clung to procedure, believing that deviation would create more danger than it solved. They feared catastrophic failure. They feared accidents. They feared the unknown consequences of altering machines, not designed to be altered. Those fears were not irrational. Modifying equipment in the field carried real risks. Frames could snap. Engines could overload. Improvised solutions could collapse under stress and make a bad situation worse. But the alternative was already killing people. And slowly, almost invisibly, a different kind of response began to take shape. Not officially, not loudly, but where necessity outweighed caution. In garages, hangars, and makeshift workshops, ordinary mechanics and logisticians began to see machines differently. They stopped viewing vehicles as finished products. They saw them as raw material. A truck was no longer just a truck. It was weight, torque, steel, and traction. An aircraft was no longer just a bomber. It was a structure that could be reinforced, patched, and sent back into the air if someone was willing to take responsibility. These were not acts of heroism in the traditional sense. They were acts of refusal. Refusal to accept that the system had reached its limits. Refusal to let men freeze, bleed, or be stranded because a rule book said, "Do not modify." And friend, this was not innovation driven by ambition. It was improvisation driven by belief. Belief that broken machines could still serve a purpose. Belief that experience mattered more than authorization. Belief that survival justified risk. No one asked for permission. There was no time. Every modification was a gamble. Every altered machine carried the possibility of failure. But as the environment tightened its grip, inaction became the greater danger. And so, quietly, the war entered a phase history rarely acknowledges. A phase where victory depended less on producing new weapons and more on keeping old ones alive. Where logistics stopped being support and became the front line. Where ordinary people, armed with tools instead of rifles, began reshaping the war one machine at a time. This is where the story truly begins. Not with a single invention, not with a single individual, but with the moment the system failed and people decided to change it anyway. To understand why these improvised solutions became necessary, it is important to understand how the Allied war machine was actually designed to function. On paper, it was a marvel of organization. Every vehicle had a role. Every aircraft had a maintenance cycle. Every breakdown was supposed to trigger a predictable chain of repair and replacement. This system worked brilliantly under controlled conditions. Factories produced standardized parts. Supply depots stored replacements. Damaged equipment was meant to be withdrawn, repaired, and returned to service in an orderly sequence. But the system was built around one critical assumption: that the battlefield would remain connected to the industrial base. By 1944, that assumption was breaking down. In Europe, rapid advances stretched supply lines to their limits. In the Pacific, geography itself became the enemy. Vast distances separated airfields, depots, and repair facilities by hundreds or even thousands of miles of open ocean. For aircraft like the B-29 Superfortress, this problem was magnified. The B-29 was one of the most complex machines of the war. Pressurized cabins, remote-controlled gun turrets, high-performance engines operating at the edge of their limits. It was designed to fight a strategic bombing campaign, not to survive constant damage far from proper repair facilities. Every mission inflicted wear. Flak tore through fuselages. Engines overheated. Hydraulic systems failed. Landing gear collapsed under stress. Under standard doctrine, a severely damaged bomber was supposed to be grounded, disassembled, and rebuilt at a major depot. But in the Pacific, there often was no depot. Aircraft returned, limping from missions with holes in their wings and cracked frames, only to find airfields overwhelmed and spare parts unavailable. Sending them back to the continental United States could take months. Abandoning them meant losing irreplaceable airframes at the peak of the bombing campaign. The same logic applied on the ground. Trucks, bulldozers, and transport vehicles were built to operate on roads that barely existed in combat zones. Snow, mud, jungle terrain, and volcanic rock destroyed suspensions, axles, and drivetrains, faster than replacement schedules could keep up. Standard maintenance could not keep pace with reality, and yet the manuals remained unchanged. Military organizations are slow to adapt for a reason. Standardization prevents chaos. Improvisation invites accident. Every unauthorized modification introduces risk. In peacetime, these rules save lives. In wartime extremes, they can cost them. By late 1944, Allied forces faced a contradiction they could not ignore. They possessed overwhelming industrial power, but they were losing operational effectiveness because their machines were failing faster than the system could repair them. The solution, on paper, was simple. Slow down, withdraw damaged equipment, wait for parts, wait for conditions to improve. But the war did not pause. Frontline units continued to advance. Bombing schedules continued to escalate. Casualties continued to accumulate. Waiting was not a neutral decision. It was a choice with consequences. This was especially true in environments where nature imposed absolute limits. In winter campaigns, engines could freeze solid overnight. In tropical zones, corrosion ate through metal at astonishing speed. Salt air, heat, and humidity degraded aircraft faster than engineers had predicted. Even newly delivered machines arrived damaged by the environment before seeing combat. The system was fighting two wars at once, one against the enemy, and one against entropy. The industrial logic of replacement assumed time was available. The battlefield reality proved it was not. As pressure mounted, a quiet shift began to occur, not in official doctrine, not in command directives, but at the lowest levels of the system. Mechanics, engineers, and logisticians began making calculations their manuals never taught them. Not, is this authorized? No. But will this hold long enough? It is one. They assessed machines, not by design specifications, but by experience. They learned which frames could take extra weight, which welds would crack, which engines could be pushed beyond safe limits for a few more hours. These decisions were not reckless. They were informed by years of working with steel, torque, and failure. A damaged aircraft that could fly one more mission might mean a factory destroyed or a supply convoy intercepted. A modified vehicle that could clear terrain or move supplies might keep an entire unit alive. The risk of catastrophic failure was real, but the certainty of inaction was worse. This created a new, unofficial category of warfare. Not innovation sanctioned from above, but adaptation driven from below. The machines themselves became platforms rather than finished products. Trucks were reinforced, weighted, altered. Aircraft were patched, stripped, and flown beyond their intended lifespan. Repair work moved closer and closer to the front, sometimes within range of enemy fire. In the Pacific, this pressure led to one of the most unusual solutions of the war. If damaged aircraft could not reach proper repair facilities, then the facilities would move to them. Floating repair ships began to appear near forward operating areas. These vessels were converted into mobile workshops, capable of structural repairs, engine replacements, and emergency modifications. They were not designed to be part of the Air Force. And yet, they became essential to keeping the air war alive. This concept violated traditional thinking. Aircraft were supposed to be repaired on land. Ships were supposed to support naval operations. The separation of services was rigid, but necessity erased those boundaries. The same logic that turned trucks into snow-clearing machines turned ships into flying repair depots. The pattern was unmistakable. When standard solutions failed, survival depended on those willing to see machines as adaptable tools rather than sacred designs. This shift did not happen all at once. It emerged unevenly, quietly, and often without recognition. But it marked a turning point. The war was no longer just about producing more weapons. It was about keeping existing ones alive under impossible conditions, and that required something no factory could mass produce: judgment, the ability to decide when rules no longer served reality, when modification was not recklessness, but responsibility. By the time these improvised solutions proved their worth, the war had already moved on. Reports were filed, statistics were updated, but the logic behind these decisions was rarely preserved. What remained were the results: aircraft that flew when they should not have, vehicles that moved when roads no longer existed, lives saved not by superior firepower, but by altered machines pushed beyond their limits. This is the context in which the story unfolds, not as a miracle, not as genius, but as a necessary response to a system stretched past its breaking point. And in the next phase, that response would be tested under conditions where failure meant more than lost equipment. It meant lives left behind. Every military system has limits it refuses to admit. By late 1944, the Allied command understood that machines were failing faster than they could be replaced. Reports documented losses. Maintenance backlogs grew. Aircraft sat grounded. Vehicles were abandoned. But the official response remained cautious. Fix what can be fixed. Replace what cannot. Do not alter design specifications. On paper, this logic was sound. Unauthorized modifications introduced unknown variables. They increased the risk of mechanical failure. They created liability. And worst of all, they undermined the illusion of control. Commanders feared a single catastrophic accident more than they feared slow systemic collapse. A truck snapping an axle in the field was visible. A bomber crashing due to unauthorized repairs was undeniable. Those failures would be blamed on the decision to improvise. But the failures caused by inaction were harder to trace. A wounded soldier who never reached an aid station. A mission canceled because aircraft were grounded. A supply column immobilized by terrain. These losses appeared nowhere in court-martials or engineering reviews. They simply disappeared into statistics. And so the rules remained. Until they didn't. At the edges of the system, where delay meant death, a different calculation emerged. Not, is this allowed? Everyone. But what happens if we don't do this? Not. This question changed everything. Mechanics, logisticians, and engineers operating far from headquarters were the first to feel the pressure. They were the ones staring at broken machines while men waited in the cold. They were the ones watching aircraft return riddled with damage, knowing the next mission was already scheduled. They understood something command structures could not. A machine is only dangerous when it stops being useful. Once it is already written off by doctrine, the risk of modifying it drops to zero. That realization opened a door no regulation could close. Across multiple theaters, unofficial solutions began appearing, not as formal programs, but as quiet experiments. A reinforcement welded here, a component bypassed there, a damaged system pushed just far enough to work one more time. None of this was coordinated, none of it was standardized, and none of it was meant to last. That was the point. These were not permanent designs. They were temporary answers to immediate problems. Nowhere was this more apparent than in the Pacific. The air war against Japan depended on sustained bombing operations across enormous distances. Aircraft, like the B-29 Superfortress, were expected to fly long missions, absorb damage, return, be repaired, and fly again. But Pacific geography made that cycle fragile. Airfields were few, supply depots were far away. Weather and salt air degraded aircraft at an alarming rate. A single damaged bomber could tie up resources for weeks. Under standard doctrine, severely damaged aircraft were grounded. Structural repairs required specialized facilities. Engines needed overhaul. Systems had to be replaced according to specification. But frontline units did not have weeks. They had hours. As pressure mounted, an idea emerged that violated nearly every assumption of air power doctrine. If aircraft could not reach proper repair facilities, then the facilities would move to them, not in theory. In practice, ships already existed with machine shops, heavy cranes, and skilled crews. Naval repair vessels serviced damaged warships routinely. They cut steel, replaced engines, and reinforced hulls under combat conditions. The question was never whether such ships could repair aircraft. The question was whether anyone would allow it. The Air Force was not supposed to have ships. Aircraft maintenance belonged on land. Service boundaries were rigid, and bureaucracy defended them fiercely. But necessity does not respect organizational charts. Quietly, conversions began. Existing vessels were stripped, reconfigured, and repurposed. Heavy equipment was installed. Workspaces were adapted. Tools meant for naval steel were turned on aircraft frames. These were not elegant solutions. They were crude, they were ugly, and they terrified safety officers. Aircraft structures were never meant to be lifted by shipboard cranes. Repairs were done in salt air. Parts were improvised. Tolerances were pushed. Every decision violated some regulation. But the alternative was abandoning strategic bombers at the height of the campaign. The men carrying out these repairs understood the risk. They knew a poorly executed weld could fail in the air. They knew an engine pushed too far might seize at altitude. They knew that if something went wrong, responsibility would fall on them. That is why many of these efforts remained unofficial. There were no press releases, no photographs staged for documentation, no requests for authorization. The work happened because it had to. Damaged bombers limped back from missions and were diverted to these floating repair platforms. Crews assessed damage not by checklists, but by judgment. They decided what could be patched, what could be reinforced, and what had to be stripped away to keep the aircraft flying. Weight was reduced. Structures were reinforced. Systems were simplified. The goal was not perfection. The goal was survival. One more mission. One more flight. One more chance. This logic echoed what was happening on the ground. Trucks were modified to operate in terrain they were never designed for. Vehicles were reinforced, weighted, or stripped down to perform a single task. If they failed afterward, it no longer mattered. These were not heroic acts in the traditional sense. They were calculated risks taken by people who understood the cost of delay. Not everyone supported this approach. Opposition came quickly and loudly. Engineering officers warned of catastrophic failure. Safety officials pointed to stress limits and load calculations. Commanders worried about precedent. If rules could be ignored here, where would it stop? These concerns were legitimate. Improvisation can spiral into recklessness. One success can justify 10 failures. And war does not forgive mistakes. But the people pushing these solutions forward were not reckless. They were experienced. They knew which risks were acceptable and which were not. They understood the machines at a level manuals could not capture. This was the critical divide. Those opposing modification saw machines as designs. Those implementing it saw machines as material. Steel bends. Frames flex. Systems tolerate more abuse than engineers are comfortable admitting. Within limits, the forbidden solutions did not succeed because they ignored physics. They succeeded because they respected it. Every modification was grounded in practical knowledge. Years of working with metal. Years of seeing what failed and what held. This is what doctrine could not codify. As these improvised systems proved their worth, resistance softened. Aircraft repaired offshore returned to service. Vehicles modified in the field reopened routes once thought impassable. Operations resumed that would have otherwise stalled. But official recognition never followed. There were no formal endorsements, no doctrinal updates during the war, no acknowledgement that the rules had been broken. The system absorbed the benefits without admitting the cause. And that was intentional. Admitting that unauthorized solutions had saved lives would mean admitting that the system itself had failed. Military institutions rarely do that. Instead, the story moved forward. Statistics improved. Missions resumed. Campaigns continued. The forbidden solutions faded into the background, their impact hidden behind broader success. But for those involved, the truth was clear. The war had crossed a line. It was no longer about executing plans. It was about adapting faster than conditions could destroy them. And in the next phase, that adaptation would be tested in moments where a single decision, made in seconds, would determine whether everything held together or fell apart. Improvisation only matters when it is tested under pressure. Up to this point, the forbidden solutions existed mostly in workshops, planning rooms, and half-finished machines. Steel had been cut, welds had been laid, systems had been altered. But none of it mattered until those machines were forced back into the conditions that had broken them in the first place. That moment always arrives without ceremony. There is no announcement, no countdown, just a problem that cannot wait any longer. In both Europe and the Pacific, that moment came when operations resumed before conditions improved. Orders were issued, missions were scheduled, convoys were told to move. The environment had not changed. The weather had not relented. Distance had not shrunk. The only difference was the machine. On airfields scattered across the Pacific, damaged bombers were brought forward. Their scars were still visible. Patches stood out against original skin. Systems had been simplified. Weight had been redistributed. These aircraft were no longer textbook examples of engineering. They were compromises. Every crew understood that. Pilots walked around their aircraft slowly, inspecting areas they normally would not have questioned. They traced weld lines with gloved hands. They looked for cracks, warping, anything that suggested failure waiting to happen. Maintenance crews said little. They knew reassurance meant nothing now. Either the machine would hold, or it would not. In the air, there is no margin for doubt. The first flights after major modifications were the most dangerous. Engines were pushed to operating temperatures under loads they had not been tested for. Structural stress accumulated differently. Vibrations traveled through altered frames in unpredictable ways. Every minute aloft was a calculation. The same was true on the ground. Vehicles modified to operate in impossible terrain were ordered forward. Roads that no longer existed were treated as obstacles rather than routes. Snowdrifts, mud fields, and broken infrastructure became tests of whether these machines could still function under strain. The gamble was no longer theoretical. Failure would not be gradual. It would be sudden and catastrophic. And for a moment, it seemed the critics might be right. Early attempts exposed weaknesses immediately. Some modifications failed under load. Welds cracked. Components bent. Engines overheated. Machines designed for one purpose resisted becoming something else. Each failure reinforced the argument against improvisation. Each breakdown was used as proof that unauthorized solutions were reckless. But something else happened as well. Some machines did not fail. They strained. They protested. They pushed far beyond their design limits. And they worked. In the Pacific, bombers that should have been grounded completed missions and returned. They did not fly smoothly. They did not fly comfortably. But they flew. On the ground, vehicles cleared paths through terrain that had previously stopped entire units. They moved supplies. They evacuated wounded. They reopened routes, written off as lost. These were not spectacular victories. There were no dramatic announcements. No single moment where the war visibly turned. Instead, the effect was cumulative. One mission completed meant another scheduled. One road reopened meant supplies moved again. One evacuation successful meant lives saved that would have otherwise been lost to exposure or delay. What mattered was not perfection. What mattered was continuity. The war machine, which had stalled under environmental pressure, began moving again. But the true test of these solutions came not in routine operations, but in moments of sudden crisis, moments when there was no backup, no alternative route, no replacement machine, no second chance. These moments revealed whether improvisation was adaptation or merely desperation. In several cases, machines encountered exactly the failures critics had warned about. A modified aircraft experienced severe vibration mid-flight. Structural stress exceeded estimates. Crew members reported unusual sounds, flexing, instability. The response in these moments determined everything. Standard procedure would have dictated immediate withdrawal. Abort the mission. Preserve the machine. But withdrawal was not always possible. Fuel limitations, weather conditions, enemy presence. Crews were forced to make decisions in seconds. Push forward or turn back and risk being lost anyway. On the ground, vehicles encountered obstacles beyond even the worst predictions. Solid objects buried beneath snow, terrain that shifted under weight, loads heavier than expected. Machines stalled. Engines screamed. Frames twisted. Steel met resistance that no blueprint had accounted for. These were the moments when improvisation either proved its worth or collapsed under its own ambition. In several documented cases, crews adapted in real time. Loads were adjusted on the move. Components were disengaged to reduce strain. Modified systems were used in ways their builders had only imagined. The machines were no longer being operated. They were being negotiated with. This was the unspoken reality of wartime improvisation. A machine pushed beyond its limits is no longer predictable. It becomes a partner in survival rather than a tool. The people operating these machines relied not on manuals, but on instinct built from experience. They listened to engines. They felt vibrations through controls. They recognized the difference between stress that could be endured and failure that could not. This kind of judgment cannot be taught quickly. It is earned. And in these moments, it made the difference between success and disaster. There were losses. Some machines did fail catastrophically. Some never returned. Some modifications proved unsustainable. Improvisation did not eliminate risk. It redistributed it. Instead of certainty of failure through inaction, risk was concentrated into moments where human judgment mattered most. This was the trade. And slowly, the results became undeniable. Operations that had been paused resumed. Supply lines stabilized. Air campaigns maintained tempo. The system, though still fragile, regained momentum. Critically, this momentum came without official acknowledgement of how it was achieved. Reports attributed success to improved coordination, favorable conditions, or routine operational efficiency. The forbidden solutions remained invisible, but within the ranks, perception shifted. Skepticism gave way to cautious acceptance. Opposition softened into silence. No one celebrated improvisation openly, but fewer people tried to stop it. Commanders learned when not to ask questions. Inspectors learned when to look the other way. The system adapted not by changing its rules, but by allowing exceptions to exist quietly. This was not reform, it was survival. The turning point was not a single battle or mission. It was the realization that the war could continue only if machines were allowed to become something they were never meant to be. The gamble had worked often enough to justify itself, but it came at a cost. Every success raised a new question. How far could this go? How much stress could these machines endure before failure became inevitable? And what would happen when improvisation met its absolute limit? That answer would come later. For now, what mattered was simple. The war was moving again. Not because conditions had improved, not because plans had changed, but because ordinary people had taken responsibility for altering the machines that held everything together. And in doing so, they had quietly reshaped how the war was fought. In the final phase, the consequences of these decisions would become clear, not in medals or recognition, but in who lived long enough to go home. When the war moved on, it left very little behind. Machines that had been pushed beyond their limits did not age gracefully. Frames weakened by stress eventually cracked. Engines driven past tolerance failed without warning. Temporary solutions expired the moment pressure eased. Most of the modified vehicles were scrapped. Many of the altered aircraft were dismantled, written off, or quietly replaced. The system erased the evidence. Official reports credited success to operational momentum, improved coordination, or changing conditions. The machines that had been altered to survive were absorbed into statistics or removed entirely. This was not an accident. Military institutions depend on order, predictability, and repeatability. Improvisation threatens all three. To acknowledge that unauthorized solutions saved lives would be to admit that doctrine failed when it mattered most, and institutions rarely memorialize their own blind spots. So the story simplified itself. Campaigns succeeded. Objectives were achieved. Losses were accepted as unavoidable. What disappeared were the moments in between, the nights spent welding under pressure, the decisions made without permission, the judgment calls that balanced mechanical failure against human survival. These moments did not fit neatly into after-action reports, and so they were forgotten. But the consequences were real. Thousands of men lived long enough to be evacuated, treated, or simply endure another day because machines kept moving when they should have stopped. Air campaigns maintained tempo, not because new aircraft arrived on schedule, but because damaged ones were kept alive just long enough. Supply lines did not collapse entirely because vehicles were forced to operate in conditions no engineer had planned for. None of this was spectacular. There were no turning points the public could point to, no single battle decided by a modified machine. Instead, there was continuity. The war did not pause. And in war, continuity is everything. For the people involved, the lack of recognition was understood. They did not expect medals. They did not expect their names to be recorded. They understood something fundamental about how large systems work. When a system succeeds, it credits its design. When it fails, it blames individuals. When it survives by bending its own rules, it pretends nothing happened. This is why logistics rarely produces heroes. It produces survivors. Years later, when historians pieced together the broader narrative of World War II, they focused on decisions made at the top. Conferences, commanders, strategic doctrines. The war was framed as a contest of ideology, industry, and firepower. But beneath that narrative lay a quieter truth. Wars are not won solely by what is built in factories. They are won by what is kept working when conditions destroy everything else. The machines that mattered most were not always the most advanced. They were the ones that could be adapted. And the people who mattered most were not always those issuing orders. They were those willing to take responsibility when orders stopped making sense. This legacy did not disappear entirely. In the years after the war, military organizations quietly absorbed the lessons they refused to publicly acknowledge. Doctrines began to include flexibility. Forward repair concepts expanded. Logistics planning accounted more seriously for environmental extremes. But these changes were framed as evolution, not correction. The original acts of improvisation remained uncredited. This pattern would repeat itself in later conflicts. New wars would again expose the limits of doctrine. New environments would again break machines. And once again, solutions would emerge from below, driven by necessity rather than approval. The story you have just heard is not unique to one place or one moment in history. It is a recurring feature of war. Whenever conditions become extreme enough, systems fail. And whenever systems fail, individuals are forced to decide whether they will follow rules or save lives. Sometimes, those decisions reshape the outcome quietly. No banners, no ceremonies, no acknowledgement, only the absence of catastrophe. That absence is difficult to celebrate. It leaves no dramatic image, no clear victory to point to, but it is often the difference between collapse and survival. The modified machines of World War II did not win the war by themselves. But without them, the war would have stalled, fractured, and cost far more lives than it already did. They were never meant to last. They were meant to hold, just long enough. And that may be the most important lesson they leave behind. Not that rules should be ignored, not that improvisation is always right, but that in moments where reality breaks the system, survival depends on judgment. On the ability to see machines not as sacred designs, but as tools shaped by human hands, and on the willingness to accept responsibility when no approved solution exists. History remembers the generals. It remembers the weapons. It remembers the victories. What it often forgets are the quiet decisions that made those victories possible, the machines that kept moving, the people who altered them, and the lives that continued because someone refused to let the system stop. That is the legacy. Unwritten, uncelebrated. But everywhere beneath the surface of history, If this story changed how you see World War II, leave a comment and share it with someone who loves real history. The machines may be forgotten, but the lessons they left behind still matter.